Scientists unintentionally discovered what really lies within a black hole. There are many mysteries and so many things we don't understand about black holes. A black hole has such strong gravity that it can suck in anything around it, even light. Maybe we should have just called them giant, heavy black objects. But wait, there's more. Wondering what else hides inside a black hole? Welcome to the Space Invaders, your home for all things space and cosmology. Whether you're a casual viewer or a hardcore enthusiast, we've got something for you. So, what really lies within a black hole? We understand what happens outside the black hole as you approach its event horizon, that infamous point of no return. The event horizon is where the escape speed exceeds the speed of light. You'd have to be going faster than light, which is impossible for any bit of matter, to escape the black hole's gravity. Inside the event horizon is where physics goes crazy. Calculations suggest that what the fabric of space-time looks like inside a black hole depends on that particular black hole's history. It might be turbulent, twisted, or any other number of things. One thing's for sure, though, the tidal forces would kill you. A black hole could be a hologram. In fact, the entire universe could be a hologram. At least that's one part of the idea behind a recent study published in the journal PRX Quantum. The study is a deeper look at what's inside a black hole. It's also an attempt to better understand the idea of holographic duality. Holographic duality is a mathematical conjecture that attempts to connect theories of particles and their interactions with the theory of gravity. It's an interesting idea, even if it sounds a little out there. Essentially, holographic duality posits that the theory of gravity and the theory of particles are equivalent. At least, mathematically. Thus, what happens mathematically in the theory of gravity also happens in the theory of particles. For the most part, both of these theories describe different dimensions. However, gravity describes 3 dimensions, whereas particle theory consists of only 2 dimensions. The researchers hope that probing this idea could help them understand what's inside a black hole. Enrico Rinaldi, a research scientist at the University of Michigan, focused on these 2 theories in the new study. He says, in Einstein's general relativity theory, there are no particles, there's just space-time. And in the standard model of particle physics, there's no gravity, there are just particles. Connecting the 2 different theories is a long-standing issue in physics, something people have been trying to do since the last century. By connecting these 2 theories and using quantum matrix models, Rinaldi and the other members of the study were able to probe holographic duality. The idea was to combine what we know about particle theory with what we know about the theory of gravity. To start, they used simple matrix models made up of blocks of numbers. It's a standard framework for quantum computers, where one-dimensional strings represent particle theory. These usually help researchers find the ground state, which Rinaldi says is important because it lets you create things from it. Using the models that they did, the researchers were able to describe what the gravity inside a black hole looks like. Is the universe really a hologram? Yes and no. When you think of holograms, you probably think of holographic communicators from science fiction movies like Star Wars. In this case, though, what Rinaldi and his co-authors are referring to is the way the inside of a black hole meets the outside. Because the inside of a black hole works of the theory of gravity, it is represented in 3D space as spacetime moves through it. However, on the surface, the black hole looks 2-dimensional. This gives it a holographic look because we do not see it as a 3D object. This is because the theory of particles does not work in 3 dimensions. As such, some believe that the rest of the universe may work similarly. However, there is no current proof to suggest that is actually the case. Again, the latest math says that the only way to describe what's inside a black hole is through numbers. Until we possess the ability to perceive the inside of a black hole in a way that doesn't mesh with our current understanding of the nature of the universe, we won't really, truly be sure if what we're seeing is all there is to see in 2D, 3D, or beyond. Thanks for watching. If you like this video and want to see more, please like, share, and subscribe. If you have any questions or suggestions for future videos, please leave them in the comments below. Thanks again, and I'll see you next time.